Okay, the next question. They asked, at what angle should the curve be bent? So here they're asking for this angle. Oops, sorry. They're asking for this angle, theta. Then how can we find it? Think. Okay, so actually we know that this car traveling along a circle like this, and we have to make sure that it stay on the highway curve, and even that the curve is being bent already, it still stay on this one. So it means that the F net, the resultant force, okay, the resultant force, the F resultant, which is like the sum of these two vectors and weight, it should result in some way that can keep the car in a circle. Yeah, so then we think, oh, it links us to think, oh, this should be something that the F centripetal, right? In a circle means that the F force here should keep the car, sorry, it should keep the cars to be in a circle towards the center. So just imagine if the car is here, then it should be towards the center like this. If the car is here, then it should be towards the center like this. Just towards the center like this, right? At on the this point, and yeah, of course, it has to be like the same in magnitude. So I didn't draw them like really exactly correct in the magnitude, but they should be the unequal to each other, okay? And it should be towards the center, and that should be the resultant of these two forces. Another thing, we want to make sure that this one just like at the same height, right? That the car would not like skid sideways or like it fall down the banked highway. So this one should be a horizontal one. Okay, so from that analysis, we can see that we expect the centripetal force, the F net, to be a horizontal one. Okay, it should be a horizontal to keep the car in the circle and also the balance on the highway as well. So from that point, we will get some special relationship between the F net and the weight. How? So now let's have a look at this one. Like we always know that the weight should be sorry, I will make this one thinner. The weight should be perpendicular to the crowd like this, right? And then now if we have the F net to be horizontal, then did you realize there's this angle here? This will be a right triangle, right? And then it will make this, it will be a right angle, and then it will make this one to be a right triangle, right? And if we got this one as a right triangle, then we can define the relationship between F net and weight like this, right? With theta is this angle. So then theta will opposite to the F net and will adjacent to the weight, right? So then we got this relationship. And actually, if we got this relationship, then we can see that F net will be just like the mass times with the acceleration. Here is will be the centripetal acceleration. The weight here, that will be the mass of the car times with g. G is the gravitational acceleration, which equals to 9.81 meter per second square. And then tangent of this angle. So it just happened that this angle is not any strange angle, but that should be the angle of the bank itself. How can that, if you pay attention, you can see that actually this triangle is congruent with this triangle, right? Because both of them also like right triangle, you see, and this angle here its side here. Oops, sorry. And the other sides here. Like each of these angle have the side perpendicular to each other, so they equal to each other. Or if you want to have another way to look at it, you can see that you pay attention to the orange, to the orange sorry, to the orange triangle here, right? Then you can see this angle here, that's very little ones here. And this one is a right triangle. Then this little one, purple ones here, that should be equals to 90 degree minus the theta, right? And then if we have a look at a little triangle here, then that angle is also make with this that angle theta 90 degree. So it just proves that they should be like the same angle. Alright? Yeah, I think it's kind of obvious to see that they should be the same, right? So after we got the result, then combine with the other ones here. This is the result from centripetal accelerations. We will cover in the circular motion that we know it will equals to the v squared over r, and v here is the tangential radius, the tangential velocity, which is like tangent to the curve and like perpendicular to the radius. This is the v here. That's the value of v. So combine them all together, we can find the relationship between the v, the radius, and the g and the angle. So basically, we want to see we want to find the angle. So then we solve for angles here. It's just like a little bit rearrange of the mass. G is here, divided both sides by g. We got the tangents of theta, and then we find a inverse functions of the tangents. Then we can find the theta is about 12.7 degree. So what is the meaning of these problems? The meaning of this problem is that you can see that the angles here and the v's here, they have a very close relationship, right? And even the radius, right? So just imagine if you travel really fast, and if the angle doesn't change, then you can see that the radius also like increasing, right? And in that case, this means that you have the more tendency to add a crater curve, and which means that you have a tendency to like skid away. And it means that there's more of the accident. Okay, and in another way to make it safer, you can also like change the tension of the angle. So if you have the theta up a little bit, then this one will like up a little bit. So if you still travel really fast, but the radius cannot be affected if you have this one up a little bit, right? But we just have to make sure that if it's too much, then at that time the car also have the tendency to go this way as well, so it's kind of like a balance between all of the parameters here. So this is actually a very meaningful result, and from there we can design safety for our transportation system. Okay, so this is cool, right? And it's very applicable to real life. Hope that you will like it better after this problem. Thank you.